Unit 8, Part 5 notes. I can use factored form to identify special characteristics and graph quadratic functions. So first, factored form looks like this. Y equals A times the quantity x minus n times the quantity x minus n. So the A value will again tell you if it is concave up or concave down. So concave up is just the U shape opens up, concave down opens down. And this is the same as standard form. So standard form, that A value also would tell us if it was concave up or down based on the positive versus negative. And so does the vertex form. So that is a consistent in all quadratics. And then we have the factors. So factored form has two factors. We have m and n. Please note that in factored form they are being subtracted. So that will change the value if it is being added. So again, it's kind of like that vertex form where when it was inside the parenthesis with that subtraction, we took the positive value, and then if it was positive, we take the negative value. So just like how we talked about in vertex form, it's kind of like opposite thinking, because we always talk about taking that sign with a number. However, in these cases, it's not that way. So m and n would be the x-intercepts of the function. So that is the information that factored form tells us. It tells us the x-intercepts. So vertex form shows us the vertex, standard form shows us the y-intercept, and factored form shows us those x-intercepts. So before we get into graphing, we want to talk about identifying those important pieces of information. So we have three equations, and we're going to identify the concavity. So does it open up or down? And then give those x-intercepts. So I'm going to just start by writing that standard form right above it of factored form. Just write that out. So my A is positive, which means the graph will open up. It'll be a concave up function. And then if we look, everything lines up. We have an x, we have a minus sign, so then we can just take that 2 value. So one of my x-intercepts would be 2, so m equals 2. And then one of my x-intercepts will be 5, because again, it all lines up. So then important to note that since it's an x-intercept, it's a graphical feature, we do need to write that as a coordinate point. So when we write that as a coordinate point, we'd have 2, 0 is one of them, and 5, 0 is the other one. All right, let's try that second one. We have y equals -4 times x plus 3 times x minus 6. So again, I'm just writing that factored form, standard form right above it. And then we can identify that concavity by our A value. Our A value is negative, which means it's going to open down. And then we need to identify those m values. So our factors, so m and n. In that first parenthesis, we can see that there is not a minus sign, it's a plus sign. So if we rewrite that as minus, it'd be x minus -3. So then that m value would be -3, not +3, because there's a plus sign instead of that minus sign. So remember, it's that opposite thinking. When it's the minus, we take the positive. When it's plus, we take the negative. So our m value would be -3. And then in our second parenthesis, there is a minus sign, so it just stays positive. So it'd be n is +6. So we write that as coordinate points, -3, 0, and 6, 0. So I'd like you to try this last one on your own, and then you can play the video to just check your work. So our A value is positive, so the concavity should be up, and our x-intercepts would be -7, 0, and -1, 0, because there's plus signs instead of minus signs, so we take the negative version of those numbers. All right, so now we are going to talk about how to graph using factored form. So we just talked about the very first 2 steps of graphing using factor form, using that a value to identify concave up and down, and then identifying those factors. So we're going to do that again. So our equation is y equals -2 times x plus 1 times x minus 3. So our a value is -2, so that means we are going to open down. Then we are going to identify that m and n value. So we have +1, which makes it the opposite, -1. And then we have that -3, which makes it the opposite of +3. So our x-intercepts are going to be -1, 0, and +3, 0. And then we are going to go ahead and plot those on the graph. Again, I do have it set up. If you're doing it digitally, you can just grab these green points, pull them over, and you can type in all the boxes. But I'm just going to draw on my screen as I've been doing here. So we have -1, 0, and 3, 0 there. All right, and the next step is to identify that axis of symmetry, our horizontal or our vertical line that goes up and down. And to do this, we're going to use this equation of x equals m plus n divided by 2. So it's a very simple, straightforward formula. We take our m value, which is -1, plus our n value, which is +3. -1 plus 3 is 2. 2 divided by 2 is +1. So our axis of symmetry would be x equals 1. And that just means it's going to be that dashed line at x equals 1. Again, here's the line for you right here to grab and place on your graph if you're doing it digitally. Next step is to find the vertex, which goes on that axis of symmetry. So we're going to use that x value from our axis of symmetry, replace x with 1, and solve for y. So that process is still the same that we've been doing in all of our formulas. So vertex, we'll use our factored form equation, and then we'll replace those x values with 1. So we get -2, and then the first parenthesis, 1 plus 1 is 2. The second parenthesis, 1 minus 3 is -2. So we need to do -2 times 2, which is -4. And then -4 times -2 would be +8. So our vertex is 1, 8. You can also take this whole piece right here. You can type that into your calculator. I would recommend using an actual scientific calculator, not the one on your phone. There is that Desmos one linked in Schoology that we've been using. So you can definitely use that to help you with your operations if you need it. So then we plot that point of 1, 8. You see that orange point on the graph. And then lastly, we are going to solve for that y-intercept. So to do that, very similar process to solving for the vertex, except for we are going to replace our x with 0, because in a y-intercept, that x value is always 0. And then we are going to solve for y. So replace x with 0. And now I'm going to show you how to use that Desmos calculator to calculate this. So we would start with that -2, and then in parentheses, we'd have 0 plus 1, and then 0 minus 3, and then we get that value of 6. So y is 6, which means our y-intercept will be on that y-axis at the value of 6. And then symmetry would dictate that we have a point at that same vertical level on the other side of our axis of symmetry, so 1 line away. And then we can connect the dots, make that parabola shape, and we can see that it does open down like we said it would. All right, so I am going to go through one more example with you. If you feel like you don't need that, you can go ahead and just go into your practice, but I am going to go through another example with us. So we have our equation y equals 0.5 times x minus 2 times x plus 6. So again, our a value is positive, so it's going to open up. And then our x-intercepts, our m value is 2. It's minus 2, so we stay positive. And then negative 6, because we're adding 6, so we make that negative. So then our x-intercepts would be 2, 0, negative 6, 0. Put those on the graph. 2, 0, negative 6, 0. All right, next step is to find that axis of symmetry. So we're going to use that formula again, m plus n. So we do 2 plus negative 6. 2 plus negative 6 is negative 4, divided by 2 is negative 2. So our axis of symmetry is x equals negative 2. You can go ahead and graph that vertical line at negative 2. So now we're going to solve for our vertex. We're going to replace that x with that negative 2 value and then solve for y. So I'll replace my x value with negative 2. And then again, we can use our Desmos calculator to evaluate. Just typing it all in, and then once we get to the end, we find out that our y value is negative 8. So our vertex is negative 2, negative 8. All right, and then that last piece is to do that y-intercept. So we're going to replace our x value with 0, solve for y. So we replace x with 0. Solve for y. Again, we can use our calculator, and this time we just have to change those negative 2 values that we put in for x to zeros. And then we see that our y-intercept is at negative 6. So y-intercept is at 0, negative 6. And then again, symmetry would dictate that we have a point at that same level, the same distance away from that axis of symmetry. So since the y-intercept was 2 lines away, we go 2 lines away on the left side as well. Last step is just to connect those dots, make our parabola shape, and we can see that it does open up like we said it would. So that's a nice way of checking to see if you're doing it correctly. All right. Classwork, you just have 4 graphs to do on your own, 2 questions to answer, and then once you've done that, you can do your check-in on Schoology, and then there'll just be a quiz as well at the end.